So today I'm going to go over what a polynomial is. So the word poly means many and nomial means many terms, or I guess nomial means terms. So when we have polynomial, it means many terms. It can have constants, variables, and exponents, but never division by a variable. The exponents of all variables must be positive whole numbers, and no variables can be inside radicals. All right, so honestly, it's kind of easier to understand things that are not polynomials, things that make an expression not a polynomial, versus like what makes something a polynomial. So basically, there's just a couple of things that will knock it out and make it not a polynomial. So here are a bunch of examples of different kind of polynomials. A couple of things to note is you can have, excuse me, excuse me. You can have multiple, my goodness, sorry. You can have multiple variables. One thing specifically, they'll ask you like the degree of a polynomial, and basically you look at the thing with the highest power. But if you have multiple variables, you just add up the powers. So like this term would be a degree 3, because we got power 1, 1, and 1. 1 plus 1 plus 1 is 3. Here, this term would have a degree of 1, 2, 3, 4, because we got 1 from that guy, 2 from that guy, and 1 from that guy. So keep that in mind when you are asked about the degree of a polynomial. If there's multiple variables, you got to add up the powers. Now, some things that feel like they're not allowed, but they are going to be dividing by a constant. You're allowed to do that. And then you can also multiply or divide by a fraction as long as there are no variables in the denominator. Additionally, you can have a square root or a radical for that matter with a number inside. However, you are not allowed to have a radical or a square root with a variable inside. So things that make things not polynomials would be negative exponents, and we know that we can't have negative exponents because we can't divide by variables. That's something that makes it not a polynomial. Here, right, we have 2 over x plus 2. We cannot have variables in the denominator, so that's no good. Same thing with like 1 over x, no good. And then again, having a variable in a radical is no good, because essentially your variables can only have positive powers or 0, or I should say positive integers. So, right, 1/2 is not a whole number, it's a fractional power. So if we have a variable with a fractional power on it, that is no good. Then there's kind of just some terminology we need to know. So the leading term is going to be the guy with the term with the highest power, right? So like here, we can see that the highest power here is going to be 5. So this entire term, this entire thing, including any signs in front of it. So like if this did have a negative, that would be included in like the leading term. Then the leading coefficient is going to be the number in front of the variable. So the leading coefficient here would just be 2. And then the degree of this polynomial would be degree 5. So you have to look at each term, whichever term has the highest power. That is how you would classify the degree of that polynomial. Now, there are kind of 2 different ways to classify polynomials. You can classify it by the number of terms, and that's going to be like if you have a monomial, binomial, trinomial, or anything more than a trinomial is just referred to as a polynomial. And then we have types of polynomials based on degree. So again, you look at the highest term. Now, a lot of the times people think that these guys here wouldn't be considered polynomials because they don't have variables, but they don't break any of the rules, right? If you don't have a variable, you can't have a variable in the denominator. You can't have a variable in with a negative power. You can't have a variable inside of a radical. So if you do just have a constant term here, that is a polynomial, and it would be considered a degree 0 because you don't even have a variable. Then we have a linear polynomial, so that would be like a power of 1 is the highest power. A quadratic is going to be highest power of 2, and a cubic is going to have a highest power of 3. Then we're also just going to write 2 others out. So if we have a quartic polynomial, that's going to be a degree 4, and a quintic polynomial, which is a degree 5. All right, so this guy here would be considered a quintic polynomial because it's a degree 5, right? And it has 1, 2, 3, 4, 5, 6 terms. So we would just classify that as a polynomial. All right. All right. So for the notes today, you have to copy down the problems on these blank sheets here. So I'm not expecting you to like copy down all of these words, but I do want you to at least copy down the thing that we're determining if it's a polynomial or not, okay? And I do want you to make note of the thing that makes it not a polynomial. Basically, as long as you have one thing that makes it not a polynomial, it is not a polynomial. So let's copy this problem down. So it's asking us if this is a polynomial or not, okay? So if you recall, I told you kind of just assume something's a polynomial until you find something that makes it not a polynomial. So if I'm looking here, this guy looks kind of suspicious, right? He has a radical. However, this guy is actually perfectly fine because there are no variables inside of the radical. So this term's fine, nothing weird. This term's fine. However, this term, this last term here, is no good because we have a variable inside of the radical. So because we have that, this guy is not a polynomial. All right. All right, let's try this guy. So here, again, does it break any of our rules? I don't have any negative exponents, variables in the denominator, variables inside radicals, so it's looking pretty darn good. So this guy is a polynomial. And then here they're asking us if it's a monomial, binomial, or trinomial. Well, this guy is a monomial because we've got one term. And then its degree is going to be 3. All right, next example. So we have 3a to the negative 5. All right, so does this guy break any of our rules? And he actually does. He breaks the rule of having a negative exponent on a variable. So this guy is not. I guess actually I should have wrote not. This guy, not a polynomial because of that negative exponent on the a. All right, next. We've just simply got negative c. So we're not allowed to have negative exponents. However, we can have negatives in front of variables, like this term back here for number 1 was perfectly fine. So this guy here actually is a polynomial. All right, and it is a monomial. And its degree is 1. Has a highest degree of 1. Because the power on this guy would be 1, even though they don't write it. All right, next one. We have b cubed minus c. All right. Is this guy a polynomial? Well, let's think. Does he break any of my rules? We look at each term. This term looks fine. This term looks fine. So it's looking pretty good. So I would say it is a polynomial. It is 2 terms. So we would say, because this is 1 term, 2 terms. Basically, the terms are like how many different things you're adding up. So this guy is a binomial. So we've got 2 terms. And its highest power is 3. Alrighty, next one. So 5, 6. And please make sure you're copying down these examples. I want to make sure you have these examples in your notes when you're trying to do this on your own. All right, so this guy, we look at him. Is he breaking any of the rules? Now, this guy looks a little funky, right, because he has multiple variables, but that's okay. None of these variables break any of our rules. So this guy actually is, in fact, a polynomial. And it's going to be a binomial because we have 1 term and then 2 terms. So we have a binomial. And to determine the degree, now this is where it gets a little bit tricky. Since we have multiple variables, we need to figure out the degree of each term. So the degree of this term is going to be 7. You have to add the powers. And the degree of this term would be 8. So the overall degree of this polynomial is going to be 8. You have to go with the term with the highest power. Alrighty. So this one. This one looks suspicious, right? However, even though we have a radical, we don't have a variable inside of the radical. So this guy is a polynomial. All right. Now there's only one term here. We're not adding and subtracting more than one thing. So this is considered a monomial. And remember, you only count the powers on the variables. So even though this 3 technically has a power of 1/2, when you're finding the degree, you only count the powers on the variables. So 3 is not a variable, it's a number. So this guy here would be a degree 5. All right. This next one, it's literally just the number 1. All right. Again, that's what we would call a constant. That is a polynomial. It's one term, a monomial. And it's going to be a degree 0. All right. And that's because it essentially has 1 times x to the power of 0. All right. This one, we've got 9c to the 5th plus 5c to the 3rd. This guy is, in fact, a polynomial. It is specifically a binomial. And my degree is going to be 5, because my first term here has a degree of 5. My second term here has a degree of 3. Remember, you only look at the powers, not the coefficients. The coefficients here are like 9 and 5. All right. So we have a degree of 5, and we are good to go. All right, next one. B squared, a squared minus c to the 3rd. So, is this guy a polynomial or not? Does he break any of the rules? He doesn't. All right, so he is a polynomial. Again, we have a binomial. We have tons of binomials and monomials here. And the degree of the first term here is 4. The degree of the second term is 3. So the degree overall is going to be 4. You got to go with the highest one. All right, let's see. I feel like we're doing pretty good on this. All right, so let's go ahead and do some of the kind of more vocabulary-based stuff here. All right, so we're going to skip ahead to question 12. So here it says, what is the leading term of the polynomial? So if we go back to our notes, okay, the leading term is the term with the highest power, okay? So if we have this, our leading term is going to be 9x. All right, it's the whole thing. All right, so if we look here at this one, it's going to take a minute to copy down. All right, so when we copy that down, first off, this guy is not written in standard form. Sometimes they'll be written in standard form, sometimes they won't be. Standard form means that you go from highest power to lowest power. Okay, now it does start with the highest power here, which is 6, but then it goes to like a power of 2, then it goes to a constant, then a power of 3. So it's not written in standard form. So just be aware that you have to make sure that you kind of search to make sure that you're looking for the highest term to find the leading term, or I should say the highest exponent to find the leading term. So here, my leading term would be this whole thing here. So it's going to be a negative 2x to the power of 6. And don't forget, if there's a negative in front of it, you have to include it. I guess we should probably write that this guy is, in fact, our leading term. All right. This one, what is our leading term here? Well, this term has a degree of 0. This term has a degree of 4. So our leading term here is going to be negative x to the 4th. All right. So here, let's copy down our problem. 8x to the 3rd minus x plus 5 plus 5x to the 4th minus 5x squared. So if we go kind of term by term, we can see that this guy is a degree 3, this guy is a degree 1, degree 0, degree 4, and degree 2. So the overall degree of the polynomial here is going to be 4. All right, and therefore that is my leading term. So we're going to have 5x to the power of 4. All right. Let's see. So we kind of took care. All right. So now let's see if they ask us the degree. All right. Oops, I'm still in highlighter mode. So again, the degree, you're just going to figure out what the term at the highest power is, and the highest power is your degree. So for this one, we've got 2x minus x to the 6 plus 7 plus 9x to the 4th. So we've got power of 1, power of 6, power of 0, and power of 4. So overall, a degree here is going to be 6. And we can write D-E-G-R-E-E. All right. Let's try another one. So we've got number 19 here. Negative x squared minus 2x plus 9 minus x to the 4th minus x to the 3rd. If we look, our leading term would in fact be negative x to the 4th. And the degree here is going to be 4. All right. All right, so the next thing we should be able to find is something called the y-intercept. So you essentially get your y-intercept when you plug 0 into any function, okay? Because like your y-intercept is going to be 0 comma something, okay? So to figure out what your y-intercept is, you would just plug in a 0 for x, and whatever you get out is going to be your y-intercept. Now, if your polynomial isn't in like factored form, if it's written out with all the like terms multiplied, this one's pretty close to standard form. We would just need to put it in order. Essentially, your y-intercept is just going to be your constant term. Your constant term is the guy with no variable attached to it. All right, so this guy doesn't have a variable. He's a constant term. Our y-intercept here is just 4. Now it says only write the y value of the y-intercept. Sometimes they want you to write it like this as a coordinate pair. But this one, they just said write the y value only. So I would just put a simple 4 there. All right. What would the y-intercept of this guy be? So this guy has no variable attached to him, so our y-intercept is going to be -1. And again, you get a y-intercept from plugging in 0 for x. So it logically makes sense, right? Like if I were to plug in a 0 for x, I would have 8 times 0 squared minus 1, which gives me 0 minus 1, which gives me a minus 1. That's why you always end up with whatever your constant term is. So let's try this guy. Now, if we're trying to find the y-intercept of this, okay, there isn't a constant term, okay? There's no term here that doesn't have a variable attached to it. When that happens, that means that your y-intercept is 0. And I'll show you why. If we go plug in our 0 for x, right, we end up with 0 minus 0, which gives us 0. So our y-intercept here would just be 0. When there is no constant term in your polynomial, your y-intercept is 0. All right. So like here, I'm not even going to write this one down, but our y-intercept would just be 2.